This will be the first session on the matrices. Numbers are generally used to give the information on a quantity. It is quite like if you need to identify um, some quantity, then you are using numbers. It is quite like if you are having how many students are there? There are 127 students. Likewise, you can have just to measure a quantity, you can use the numbers. But if you are using matrices, matrices can be used to give information on two or more quantities in such occasion given below. It is quite like matrices also. First, we have discussed on what is a number. Number is just giving an information regarding quantity, and then using the numbers we can creating the matrices. If you are if you are interested in two or more quantities, then we can use the matrices to denote them. As an example, it is given that three students naming A, B, and C got their prices for the examinations. It is quite like this. Think about there are three students in your class, and they got the prices. If we are naming the student A, student B, and we know that third student is student C. And if you look on the passes that they have got, A has got a price as it includes 6 exercise books. There are 6 exercise books, and there were 3 pens. There were 3 pens. If you see on the gift for the student B, that student has got exercise books. The number is 4 exercise books, and there were 2 pens. If you see on the student C, there was 3 exercise books, and they are not giving any information regarding the pens. Therefore, we can assume that pens are equal to 0. Therefore, this is the information that we are having. Now, if we are going to represent this information, what we can generally do is we can generally use a table to show this information. It is quite like this. If you can create a table in this form, in the first column, you are writing the student name. We can say it is A, B, and C. And in the second column, you may write number of exercise books in the parser, number of exercise books. Then in the next column, you can say that number of pens in the parser. If you tabulate the information that you are having, you know that for the student A, there were 6 exercise books and there were 3 pens. For the student B, there were 4 exercise books and there were 2 pens. For the student number C, or for the student name C, there were 3 exercise books but no any pens. Therefore, this is how we are tabulating the data that we have experienced. Therefore, once you are tabulating the data in this form, then we can convert this into a form of a matrix. Therefore, we can simply convert this table into a matrix. Therefore, if you are just using these numbers, now think on the numbers you are having. Here it is 6 and 3. Then you are having 4 and 2. Then you are having 3 and 0. Now you can see that you have created the matrix. Therefore, if you are creating the numbers in this form, I will write it like this. If you can write the numbers in this form, then we can say such an arrangement is said to be a matrix. Therefore, the information that you are getting in this form can be illustrated using a matrix as this. Now we will move for the definition of a matrix. We'll see what is given as the definition of a matrix. A matrix is said to be a rectangular array of numbers. It is the general way that we are defining a matrix. Therefore, matrix can be identified as a rectangular array of numbers. Here you can see that if you see on the shape that the matrix we have obtained, here we can see this is the shape that we have obtained. It is just a rectangular array of numbers. There were three rows and there were two columns in this matrix. Therefore, in generally we can say that matrix is a rectangular array of numbers. Since this is a rectangular array of numbers, in here I have identified that there are three rows and there are two columns. In generally, to denote a matrix, then we can say that matrix is a rectangular array of numbers having m number of rows, number of rows is m, and we can say that number of columns equal n. Therefore, if this array has m number of rows and n number of columns, then we say such a matrix is in the order of m by n. This is just a notation only. It is not implies the multiplication like 3 multiplied by 2 equals 6. This is not the idea behind this. This m by n, it is just if it is 3 by 2, it is just we can say this as 3 by 2. This is what we are saying as the order of the matrix. This is said to be the order of the matrix. Therefore, if you can see or if you can identify a rectangular array of numbers having m number of rows and n number of columns, then such arrangement can be considered as a m by n matrix, and we can say that m by n as the order of the matrix, or we can say that it has the dimension of the matrix as order or the dimension of the matrix. Here, if you see on this example, we can see that the matrix is written as 6, 3. Here it is given as 6, 3, 4, 2, 3, 0. And you can see that order is given here as 3 by 2. Therefore, generally, the order of the matrix is denoted at the bottom right corner of the matrix. Generally, in the bottom right corner of the matrix, we are writing the order of the matrix. Now we will move for the notations on matrices. Matrices are generally written using the box bracket or the parentheses. In the previous matrices, you may see that I have written it as 6, 3, 4, 2, 3 and 0. There, in the initial one, I have used the box brackets to denote the matrix, and thereafter, in the next time, I have used 6, 3, 4, 2 and 3, 0 using parentheses. Therefore, you can write down a matrix using the box brackets, or you can use the box brackets, or else you can use the parentheses. And generally, matrices are symbolized using the uppercase letters. Therefore, generally, we can use the English uppercase letters, such as we can say A is 634230. Here, since I am take B equals 634230. Likewise, we can say X equals to 5746. Likewise, you can write down the matrices, and another may say that Y equals 357140 minus 2, 1. Likewise, we can say it is a 3 by 3 matrix. Likewise, we can say using the uppercase letters, we can show a matrix. Generally, we can use one of the letters in the English alphabet. But generally, we are not going to use the letters such as letter I to denote a matrix. It is because this is used for the special notation For identity matrix, we will discuss that matter as well. To denote the identity matrix, we are using the letter I. Therefore, apart from this letter I, all the other English uppercase letters can be used here to denote the matrix. And generally, I told you that initially we are denoting the numbers inside the matrix, but for some situations, we may use the these unknown terms. When we are including unknown terms inside the matrix, generally we have to follow this rule. Generally, we have to use the lowercase letters as the elements of the entries of the given matrix. As an example, if I let P be the matrix, then if I am having it as just as numbers, then I can say A, B, C, P, Q, R, and X, Y, Z. Likewise, I can write down the values of the matrix. Here it is a 3 by 3 matrix. Now you can see that here I have used the uppercase letter P. It is to denote the matrix, and inside this matrix, the elements, or we are saying this as elements or the entries of the matrix. Altogether, there are 9 elements inside matrix, or 9 entries in this matrix. Therefore, we can say that we can denote these entries or elements using the lowercase English letters. Therefore, this is how we are using the notations in matrices. If you are moving further on these notations, this is another notation that we are generally that we can use to denote a matrix. Here I will take only one instance on these two. It is because in the first one in here we can see that box bracket is used. Here parentheses are used. Therefore, I will take only the first instance. The only difference between these two instances are box bracket and parentheses only, but all the other concepts are same. I told you that generally we can denote a matrix using the uppercase English letters, while the elements can be denoted using the lowercase letters. Therefore, when you follow that concept, here we can add row and column numbers as well to this element. Therefore, if you are writing a numbers instead of these letters, then we do not need to worry on this writing the row and column numbers. But if you are just using this, what we are saying as these unknown terms or just the English letters, then there is a concept like this to write down the elements. If you think on this point here, you can see that this is the first row and the first column. Since this A is the element in the first row, first column, then you can write this as A11. Here we can say, if I write it here, A11, the first value denotes the row number and the second value denotes the column number. Therefore, this is how we are getting it. First value denotes the row number and second value denotes the column number. Therefore, A11 stands for the element in first row, first column. If you move further on this, then I will get this as A12. A12 is first row, second, the element in first row, second column, element in first row, second column. Likewise, if you see that there are n number of columns and m number of rows, and n number of columns. Here we can say this as, since we are still in the first row but in the nth column, therefore we can say that the element at this point is A1n, since it is in the first row, nth column. Then we can move to the second row. Then we can use the notation as A21. It is because this A21 is the element in the second row, first column. Likewise, we can write the next element as A22. It is now second row, second column. Likewise, if you move further, we can have this as A2n. A2n is the second row, nth column. Likewise, if you move down on the down up to the mth row, then we can say this as the element in mth row first column. Then this will become the mth row second column. Likewise, we can move for the A, M, N. Here it is the mth row, nth column. Likewise, we can have the values here and we can say it is the order is M by N matrix. Therefore, this is how we are using the notations in matrices. Therefore, if you are learning further on mathematics, then these notations will be used. But generally in the applications, we are not going to worry on these notations that much. It is because we may have it like this. It is because we are having 3, 5, 7, 1, 6, 4, -2, 5, -3. Likewise, we may have the values. Therefore, here we just need to identify what is the position of this element only. We are not interested in writing this as 3, 1, 1. We are not going to write it in that way. Since these are just using the notations only, we are including the row numbers and the column numbers. Otherwise, instead of using these positions in this as the including row numbers and column numbers, we are directly using the elements or the numeric formats in the matrices. And if you can see on this, the third equation here, I have written it as A equals Aij, and I have written down order of this matrix is M by N. It is quite like this. It says that where I goes from 1 to M. Therefore, the possible values of I is starting from 1 and ending from N, and the possible values of J is 1, 2, 3. Likewise, we can have the values up to N. Therefore, if you are substituting the values, then you can again obtain this matrix. Therefore, if it is I equals 1, J equals 1, then you will get this element. Then if you have it in this way, now think on if it is here you are having 1 and here you are having 1, then you may able to get the what we are calling as the first element. It is first row first column element. Now think on the, if you are substituting I equals 1 and J equals 2, then I is it is in the first row and here J is 2. Therefore, we can say this element has obtained. Likewise, if you are having I equals M and J equals N, then you will get the element in the row number M and column number N. Therefore, in that method, we can easily identify what we are saying as the position of the element. Here it is explained as A equals Aij M by N. It is the order of the matrix where I is the row number and J is the column number. Here this has to be corrected. It is simple Aij represent the ith row and jth column of matrix A. This is just for the notations of matrices. Now we will move for the types of matrices. If you look on the types of matrices, there are several types of matrices that we have to pay our attention on. The first matrix that I am going to discuss here is the null matrix. In the word itself, it is saying as null. Therefore, we can say that a matrix having all the elements as zeros, then such matrix is said to be a null matrix. Here we are not going to worry about the order of the matrix. The only condition which needs to satisfy to be a null matrix is all elements should be equal to 0. Here I have taken a 2 by 3 matrix. Here we can see that 2 rows and 3 columns are used. and you can see all the elements, all the 6 elements are equal to zeros. Therefore, here we can say that A is a null matrix. We can say that A is a null matrix. Likewise, if I am taking another example, if you let B is a 2 by 2 matrix having all the elements as 0, it is a 2 by 2 matrix, then we can simply say that B is a null matrix. It is because we can see all the elements inside this matrix B is zeros. That is why we can say that B is a null matrix. That is why I told you previously as well, the order of the matrix will not affected on being a null matrix. Only thing we have to pay attention is the value of the elements of this matrix. If all the elements of a given matrix are 0, then such matrix is said to be a null matrix. A null matrix is again called as the zero matrix as well. It is because all the elements of this matrix is 0. And the next type of matrices I am going to discuss here is the row matrix. At the beginning of this session, I told you that a matrix is a rectangular array of numbers. Generally, we are saying that matrix is a rectangular array of numbers. If you see on the second type of matrix, it says that this is a row matrix. Therefore, we can say if a matrix having only just one row, then such matrix is said to be a row matrix. In this example, we can see that here if you let A is a matrix having the elements as 6, 5, and 4. In this form, you can see that there is only one row but 3 columns. Since you are having only one row, then we can say that A is a row matrix. That is why we are saying that A is a row matrix since we are having only one row. In here, if you are having B is B as 2, 5, and 7. Here also you can 2, 5, 7, and 9. If you see on this matrix, this is a 1 by 4 matrix. Here also you can see only one row. Therefore, we can say that B is a row matrix. Therefore, if you are having a matrix having only one row, then such matrix is said to be a row matrix. Then the third type of matrix, it is the column matrix. At the previous one, we told that if a matrix having only one row, then such matrix is said to be a row matrix. Therefore, if a matrix having only one column, then such matrix is said to be a column matrix. As an example, if you see on this, in this matrix, it is 1, 3, and 9. If you see on this matrix, here you can see that there are 3 rows and 1 column. Since you are having only one column, then this is a special type of matrices. Therefore, we can say that A is a column matrix. A is a column matrix. If I let another example as this, if you take B is equal to -1, 0, +1, and 7, then we can say B is -1, 0, +1, and 7. Then we may say that B is a column matrix. Here we can see that it is there are 4 rows and 1 columns. Since we can see that there are only one column, then such matrix is said to be a column matrix. The next type of matrix I'm going to discuss here is the square matrices. In the beginning, I told you that matrix is a rectangular array of numbers, but if the number of rows and columns are equal together, then the rectangular itself becomes to a square. It is quite like this. Now, if you see on this shape rectangular, it has these two sides are equal, these two sides are equal. But if the four sides are equal, then this rectangular becomes as a square. Therefore, using this concept, we can define the square matrices. Generally, a matrix is said to be a rectangular array of numbers, but if the number of rows and columns of a matrix are becoming similar, then such matrix is said to be a square matrix. Therefore, using the general notation, we can denote it as matrix A. Here we can see that if it is 2, 5, or 3, 7, here you can see that there are 2 rows and 2 columns. Then we can say that A is a square matrix. A is a square matrix. If we let this be equals 4, 7, 4, 2, 7, 3, 6, 1, and 1, 5, 2, this is a 3 by 3 matrix. Therefore, we can say again that B is a square matrix. It is because we can see that number of rows and the number of columns are equal. Therefore, if we are having a matrix having equal number of rows and columns, then such matrix is said to be a square matrix. The next type of matrices that we are going to discuss for today is the diagonal matrices. A diagonal matrix is a matrix having non-zero elements only in the diagonal running from upper left to the lower right. And the next important thing on the diagonal matrix is we are defining the diagonal matrix only for the square matrices. Therefore, every diagonal matrix should be a square matrix. Therefore, no any rectangular array of numbers or any matrices having the rectangular shapes. We cannot identify any diagonal matrices. Therefore, if it is a diagonal matrix, then it must be a square matrix. As an example, if you see on what is actually meant by this diagonal matrix, but prior to that, I will let this as well. If this is a 2 by 2 matrix, if this is a 2 by 2 matrix having the elements A11, A12, A21, and A22. These are the elements that we can see here. And if you are drawing a line from the upper left to the bottom right, then this is said to be the main diagonal of the any given matrix. Therefore, if you can see the elements, here we can see this is the main diagonal, and if we are see the elements which are not on the main diagonals are zero, it is quite like. Now think on this matrix. Here you have construct the main diagonal, and if you see all the other elements, these are the other elements, we can say if all these elements are zeros, then such matrix is said to be a diagonal matrix. Therefore, on the main diagonal, we are having some non-zero elements, but all the other elements apart from this main diagonals are zero, then such matrix is said to be a diagonal matrix. As the next example, if I let B is a 3 by 3 matrix, it is quite as 1 0 0 0 5 0 0 0 9. In this situation, if you see on the main diagonal, which is coming from the upper right, upper left to the lower right, then we can see this is the main diagonal. Now you can see all the elements which are not on the main diagonals are now zero. Here we can see all these elements are zeros. This is element having the value 0, 0, 0. All these 6 places you can see zeros. Therefore, the elements which are not on the main diagonals are zero. Therefore, we can say that B is a diagonal matrix. Therefore, based on the values that you can see on the see, apart from the elements on the main diagonals, if all such elements are zeros, then such matrix is said to be a diagonal matrix. And based on this diagonal matrix, we are defining the upper triangular matrix as well as the lower triangular matrix. In the next session, I will discuss on these patterns on the upper triangular matrices, lower triangular matrices, and some other theories related with the matrices. Then this is all for this session, and thank you all for participating to this session.